Hello, everyone. My name is Austin, and I'm going to be talking to you about our coffee grinder DfM interim report. Other than myself, my team includes Benjamin Ewing, Ethan Lee, Jason Yuan, and Jay Stather. Our product has a few functions that we think are pretty interesting. The first being that our customers are going to be able to manually grind coffee to a variety of sizes, and also with these sizes, keep to a consistent grind size throughout its entire mechanism. Additionally, it can hold coffee beans and catch and hold coffee beans until it is ready to be used. And we expect to have about a production volume of 100,000 units per year. This is a CAD assembly drawing of our entire design that we can see with the different sections and the cutouts. You can see at different points in the Z direction. You can see what parts are there and what aren't. And this is pretty much just the casing and rotating mechanism just on the outer interior of it. This is our exploded view of the coffee grinder in CAD, showing all of the different parts that go into making the entire assembly. But in this case, we left out any kind of fasteners. For this product, we expect two main sets of customers. Our primary customers, we expect to have about 3/4 of our production volume. So in more specifically, about 75,000 units per year. And these people are mainly customers that are looking for a cheap alternative to expensive electric coffee grinders that you can see in the market. Whereas our secondary set of customers are for people who are on the go. This is a very easy way and storable way of being able to make a product that makes coffee for them when they're in these outdoor or on the go kind of situations.
All right, so the task function of our coffee grinder is to prepare coffee beans to be brewed into coffee. So in order to do this, the two primary functions of our product are to grind the beans and contain the grounds once the beans have been ground down. In order to grind the beans, this product needs to contain the beans and then crush the beans into grounds. To assure the dependability of this product, it prevents cuts and prevents leaks. To prevent cuts, it guards the user's hands from the blades. And to prevent leaks, it seals the grounds within the coffee grinder. To assure the convenience of this product and ease the grinding, make the grinding as easy as possible, we provide a convenient and easy to use grip on the handle that actually does the grinding. In order to enhance the product, we reduce the size, making it more lightweight. And to please the senses, the product has a smooth body, and while grinding, you can both smell and see the grounds.
Now I will talk about the assembly sequence of the grinder and then how we analyzed two of them. You can see here that the grinder is composed of three different sub-assemblies, the top, the middle, and the bottom. Here's a closer view of the top sub-assembly. And here's a closer view of the middle sub-assembly. Because we thought that there are three different sub-assemblies in this grinder, one assembly sequence that we considered was to build each sub-assembly and then assemble them into the final piece. Now you can see here that we start with the bottom sub-assembly, then build the middle assembly, and then add it to the bottom sub-assembly, and then finally finish with the top sub-assembly. Another assembly sequence we considered was to use a sort of bottom-up sequence, starting with the bottom pieces and then adding each piece individually. You can see here that there still are some sub-assemblies, and that is because the middle sub-assembly could not be added one piece at a time. It had to be built first and then added into this assembly. And then here's a comparison of these two sequences. They were pretty similar in terms of just using transfer and handling and also locating parts because it's pretty one-dimensional. However, the ease of fastening and joining and then assembling in parallel favored the first sequence because it was easier to build each assembly first and then add them together with these locking pieces that this grinder has. And here is the function component mapping matrix where we listed each component and then also listed each function from the fast diagram and then just matched what functions each component performs.
To proceed with the product's family design, we first start with the functional differentiation table, where we separate functions from the fast diagram based on whether they're the same for both or different between customer groups. Functions that are the same for both groups are contain beans, crush beans, contain grounds, guard hands, seal grounds, seed grounds, and smooth body. Functions that are different for each group are reduced weight and ease grip.
Our initial costs were rough estimates based on other similar parts that we've found on other websites, as well as our best guesses as to parts that we could not source. Things like the ceramic grinder portions. Our total part cost right now doesn't include any processes, but considering that this product is $10 total in parts, we could see that assuming it doubles in cost, this is similar to other products on the market that range in cost from $35 to $65. So we're in the correct ballpark already as soon as you include that process cost. In addition, there are many parts that we would like to remove from this full assembly. In addition, we would like to better get estimates for parts that are made out of ceramic materials.
Next, we have the component commonality table, which shows which components are common or different between the customer groups. The handle knob and bottom barrel were chosen as the modules to allow for variety of the coffee grinder. For the primary products variant, we used the current design, and for the secondary products variant, we made the handle larger for easier grip, and we made the bottom barrel out of a lighter material, namely aluminum instead of steel. From the assembly sequence analysis, sequence 1 was determined to be the better assembly sequence and is shown in the diagram labeled original assembly sequence. The assembly sequence was modified using delayed differentiation so that the bottom barrel, which was originally assembled as the first step, is now assembled as the last step.